Chocolate production. Chocolate production starts with harvesting coca in a forest. Coca needs to be harvested manually in the forest. The seed pods of coca will first be collected. The beans will be selected and placed in piles. These cocoa beans will then be ready to be shipped to the manufacturer for mass production. Once a company has received a shipment of cocoa beans at its processing plant, the beans are roasted, first on screens and then in revolving cylinders through which heated air is blown. Over a period of 30 minutes to 2 hours, the moisture in the beans is reduced from about 7% to about 1%. The roasting process triggers a browning reactions in which more than 300 different chemicals present in the cocoa beans interact. The beans now begin to develop the rich flavor we associate with chocolate. Roasting also causes the shells to open and break away from the nibs, the meat of the bean. This separation process can be completed by blowing air across the beans as they go through a giant winnowing machine called a cracker and fanner, which loosens the hulls from the beans without crushing them. The hulls, now separated from the nibs, are usually sold as either mulch or fertilizer. They are also sometimes used as a commercial boiler fuel. Next, the roasted nibs undergo broyage, a process of crushing that takes place in a grinder made of revolving granite blocks. The design of the grinder may vary, but most resemble old fashioned flour mills. The final product of this grinding process, made up of small particles of the nib suspended in oil, is a thick syrup known as chocolate liquor. The next step is refining, during which the liquor is further ground between sets of revolving metal drums. Each successive rolling is faster than the preceding one because the liquor becomes smoother and flows easier. If the chocolate being produced is to become candy, the press cake is remixed with some of the removed cocoa butter. The restored cocoa butter is necessary for texture and consistency. And different types of chocolate require different amounts of cocoa butter. The mixture now undergoes a process known as conking, in which it is continuously turned and ground in a huge open vat. The process's name derives from older vat, which resembled large conch shells. The conking process can last from between 3 hours to 3 days. More time is not necessarily better, however. This is the most important step in making chocolate. The speed and temperature of the mixing are critical in determining the quality of the final product. At the end of the conking process, the chocolate is poured into molds, cooled, cut, and wrapped. Combustion engines contribute to greenhouse gas accumulation in the atmosphere and are responsible for climate changes. A sane Sober revision of vehicle use is long overdue. While ethanol has been championed as an alternative to petroleum fuels, it mainly helps to reduce dependency on oil producing countries. Ethanol or methanol can be blended with gasoline to reduce petroleum dependency. Gasoline engines can use up to 10% ethanol without modification. New flex engines can use higher percentages of blend of 15% gasoline with 85% ethanol. The production of flex engine vehicles has increased, but the supply of flex fuel is limited. There are some problems in the bigger picture of carbon consumption and emission. When ethanol is made from corn, some energy value up to 70% in the least efficient plants must be spent on its production. While innovations in production technologies continue, there will be an ongoing requirement to invent new methods of production. Investment in new technologies will require government policy changes, subsidies, and research grants. Climate change with extreme weather events may reduce corn production in the US, where for decades corn surpluses were common. The new competition between ethanol plants and food production suddenly in 2008 became an international issue. If you are an optimist, you might argue that improved technologies will save the day. Corn yields per acre have been increasing mostly because of genetic engineering, so that food and ethanol production need not compete in the future. The ethanol industry uses only the carbohydrate friction of the corn. The protein and oil frictions are used as animal feed. If you are a pessimist, you might point the recurrent droughts in recent years in the US corn producing regions and predict more crop failures in years to come. Other non food vegetable sources of carbon will become alternative sources of raw materials.